So methane is an extremely potent greenhouse gas that's roughly 86 times more potent than CO2. Now, unfortunately, methane is released into the atmosphere in larger and larger amounts each year. So to help alleviate this issue, my lab aimed to devise a fuel cell that will partially oxidize methane into methanol. Now, methanol is an alternative fuel to natural gas that is much safer to handle, easier to transport, and much less polluting to the environment. Now, unfortunately, it's impossible to get a perfect selectivity for the oxidation. So this project investigates sequestering any remaining overoxidized methane, or CO2, into non-polluting products such as baking soda and hydrochloric acid. Now, the way this study works, or this fuel cell works, is methane is inputted and oxidized into CO2 over here. And this is combined with the OH minus to make bicarbonate. And this could also change into carbonate. Now, the Na plus that comes from the NaCl input over here combines with the bicarbonate and carbonate to make sodium bicarbonate, or baking soda, and sodium carbonate. Now, the Cl minus from the NaCl comes over here and combines with H plus to form hydrochloric acid, or HCl. Now, the study determines the optimal inlet pressure and inlet NaCl concentration using COMSOL version 5.5, which is a modeling software. Now, these optimal conditions occur when there is the smallest amount of excess CO2 and there is charge neutrality. Now, these conditions were determined to be 7,000 Pa for the inlet pressure and 2 moles per meter cubed for the NaCl inlet concentration. Now, this data can be used to develop a carbon sequestration fuel cell that will eliminate carbon emissions from methane oxidation and produce a valuable fuel in methanol. This in turn will significantly reduce carbon emissions, thus helping our current climate crisis.